Our next question is to generate and verify random sequences with arbitrary distributions, means and variances for Rayleigh distribution, normal distribution, and Poisson's distribution. So we will start with Rayleigh distribution. To make these terms more clear, we can take the help of the MATLAB. I will write here help RAYLPDF. This is the command for the Rayleigh probability density function. As soon as we write this, the MATLAB will automatically tell us that this is the Rayleigh probability density function. Herein, we give the output variable as y is equals to the syntax here x comma b, wherein it returns the density function with parameter b at the values in x. So let us try how does it work. So first we define a time range. Say I give the maximum time range but with very small time intervals and put a semicolon so that these values are not displayed. Press and enter. I define my output as y1 is equals to, again the same syntax, RAYL probability density function. I use a bracket, my input x comma. See, we can take any value. I take the constant b as 4 and a semicolon. We will be viewing the graph, but before that, let us do the syntax for all the probability density functions. Next is the normal probability density function. So I'll write here help norm, NORM, PDF and press and enter. So let us see, what does it say? It is the normal probability density function, and here I have mu and sigma. And the default values are 0 and 1 respectively. So let us do this function. Again, with the same time interval, I write here y2 is equals to NORM PDF brackets, the same my input variable x comma 0 comma 1 and a semicolon here. Our next is the Poisson's distribution. So again, I'll write help here, POISS PDF, Poisson's distribution, and press and enter. So what is this? It tells us that this here we put a lambda here, and this lambda takes the values at the x. Right? So my output this time variable is y3 is equals to POISS PDF brackets x comma, say any value. I have taken here 4 and a semicolon. So since we have done all the probability density functions, let us now start plotting these functions and see how does it look like. Since I need 3 graphs, so I have defined it as 3, 1, 1. Since we are doing it in a continuous case, so I'll write here plot. Why? Because plot is used for a continuous. In discrete, we use the stem command. So I'll write here x comma y1 for the first case. Next, again, I'll put a subplot. And this time I'll use the second quadrant and I'll put the command as change this variable to y2. With the help of the up arrow key, I am doing these changes. And the 3 and plot here for the y3. So let us see how does my graph looks like. Here we have shown the graphs. These are the graphs. The first is the Rayleigh probability density function. This is the normal probability density function, and this is the Poisson's probability density function. We can do it for discrete also, and this is in discrete only the stem has to be written. Thank you.